First topic to discuss is about numbers. Let's just extend a bit our view on numbers. So in primary school, we essentially learned that numbers can be put into a number line, which can be extended. So there is a 0, so the number line can go into the other direction as well. There is a unit on it, which we call 1, and then the numbers here, we say that this is like the x-axis. So the numbers here are part of the real numbers. But then we can get some equations, some quadratic equations, where we would need to take the square root of negative numbers. And in high school, we usually just say that, okay, this problem cannot be solved in the set of the real numbers. So in mathematics, that's easy to resolve. Let's just say that we introduce a new unit, which we call I. So I is going to be defined as the square root of -1, and that essentially means that in this already existing number line, we have a new axis. We call that these are the imaginary numbers. So these were actually the real numbers, the real axis. And so here we introduce I to be the unit. And so from now on, any number which we discussed earlier is going to be a point in this plane. So let's just say that I move A much on the real axis and I move B much in the imaginary axis, and this point is going to be our new number. It's A times the unit the real axis, which is 1. So multiplying A with 1, I'm just going to get A, plus I add B times the unit in this axis, which was I. So this is a general description of a number, and then I could call this number Z. So Z and also I is going to be the element of the complex numbers. By the way, it's also true that if a number is part of the real numbers, then it's also going to be the element of the complex numbers. So any number here is going to be a complex number, but I can, so like the number 3 is a complex number, but the number 4 plus 5i is also a complex number, right? This has, in this case, we said that A was 4 and B was set to 5. Okay, so we can actually introduce another way to describe the same thing. So let me introduce a line which connects this point to the origin, right? So that didn't actually happen correctly. That's what I wanted to do. What I wanted to do was something like this. So I'm going to call this R, and then this R is going to introduce us an angle which I'm going to call theta here. So from our trigonometrical geometrical knowledge, we know that A is going to be R. This is a triangle, right? This is a perpendicular point here. This is R times cosine of the angle, which I called theta here. And then the B is going to be R times sine of that theta. So from these two, we can say that the complex number Z can be expressed as R times cosine of the angle plus I times the sine of that angle. So again, some examples as we could do. So here we had some examples already. So some examples with this new form, or like getting back what we already have seen. That like if I put r to be 1 and the angle to be 0, then sine of theta, which is 0, is going to be 0. Cosine of 0 is 1. So this leads us that our complex number z1 is going to be just the number 1. If I keep r to be 1, but theta, sorry, is going to be pi over 2, then this is the other way around. The cosine is going to give me a 0, and then my sine is going to give me a 1. And since the r was still 1, this number z2 is going to be I, which is the reminder that is the same square root of -1. And actually there is a third form of expressing this, which I think we will come back a bit later, that the any z complex number could be expressed as r times the exponential of I and the angle theta. This is actually the equivalent of r times what we had earlier, saying that it's cosine theta plus the I sine theta. So that's the way to expand complex numbers. It's going to be very relevant for quantum mechanics. So and then also it's a relevant thing for engineering as well. So that's all for extending our numbers.